We're working through the final exam FRQ review problems, preparing for the fall AB exam. So let's look at number 1 here. We have a piecewise function, g of x equals x squared plus x minus 2 over x minus 1, where x does not equal to 1. However, that point is being defined at y value of 5. So we know that there's an order pair at 1, 5. So the problem says use limits to determine or show that the function is discontinuous at x equals 1 and state why it is discontinuous there. And part B, determine if the discontinuity is removable or non-removable and state why. Okay, so let's review continuity conditions. So continuity conditions, first off, we need to identify where the point is and make sure that the point exists, f of c exists. Next, we want to know, does a limit exist at that point? Okay, and if it's a piecewise function where the graph is split on either side with two separate branches on either side of the x value, then we need to go through a one-sided limit. Okay, but once we determine if the limit exists and the point exists, then the third thing to test is to see, does the point exist where the limit exists? Okay, look to see if A and B agree with each other. So the point that we are concerned about is that x equals 1. So first step, f of 1, does f of 1 exist? F of 1 does exist at 5, so that's our order pair. So part 2, or condition number 2, does limit exist? Now notice that this function exists to the left and to the right of 1. So there's not really a need to do one-sided limit. Now, one-sided limit is more useful and much more needed if we have two piecewise functions. One is existing purely to the left of 1, and then the other is existing to the left of 1, to the right of 1, to the left of 1. If they're on either side, if we're two separate branches on either side, defined by two separate piecewise, then we do definitely need to go through one-sided limit. But here, the graph exists to the left and to the right using the same piecewise, so we can just simply find the limit of this function. Okay, so limit as x approaches 1 of x squared plus x minus 2 over x minus 1. We know the limit is going to exist since the graph exists to the left and to the right of 1. So if we plug in 1, we're going to get 0 over 0. So we look to see if we can factor. So numerator factors out to be x plus 2 times x minus 1 all over x minus 1. X minus 1 cancels out, and we're left with x plus 2. Reevaluate the limit, plug 1 in for x. 1 plus 2 is 3. So the limit exists at 3, but the order pair is at 1. So first two condition passes, but the third condition will fail because g of 1, the order pair, does not exist where the limit exists. Okay, so the graph is connecting to a y value of 3, but the order pair itself is at a different point. So because the third condition fails and the first two passes, we know the limit exists, but there's a hole in the graph. So we can say that g of x has removable discontinuity since the limit exists, but the third condition fails. G of 1 does not equal to a limit as x approaches 1 of g of x. Okay, number 2. Find the point y equals square root of 3x minus 1 where the tangent is perpendicular to the line 3y plus 2x equals 3. Then write an equation of the tangent line to the curve at that point. Okay, so we first need to figure out what slope we're trying to target. Okay, we're trying to find the equation line to the curve, but we want to know what slope we're trying to target. So first off, we know that this tangent line is going to be perpendicular to 3y plus 2x equals 3. So if we can find the slope of this line, then we can make the adjustment to figure out what the perpendicular slope is to that line. Okay, so I'm going to try and get this into slope-intercept form. 3y plus 2x equals 3. Okay, solve for y. So get 3y by itself, 3 minus 2x, or negative 2x plus 3. Divide both sides by 3. So I get negative 2/3 x plus 3 over 3, which is 1. So the slope of this line is negative 2 over 3. But we don't want that the slope of this line. We want the slope that's perpendicular to that line. So if the slope of this line is negative 2/3, then the perpendicular slope must be opposite reciprocal or negative reciprocal. So opposite reciprocal will be we flip the slope to be 3/2, and then we change the sign. So negative becomes positive. So the slope that we're after is 3/2. We're trying to figure out where on this curve is there going to be a slope of 3/2. Okay. So what we need to do is we need to find the derivative and set the derivative equal to the slope that we're targeting, so we can locate the x value where that is going to occur. Okay. So first I'm going to find the derivative. So the derivative, 3x minus 1 to the 1/2. Well, this is the rewritten form with the rational exponent. To find the derivative, we have to go through chain rule. So bring down the 1/2, keep the parentheses, subtract 1 from the exponent, and multiply by the inside function's derivative. So 3x becomes 3, negative 1 goes to 0. Okay, so we're left with y prime is equal to 3 over 2 root 3x minus 1. We have our derivative function, and we have the slope that we're after. Okay, so if we set the slope equal to the derivative function, and if we solve for x, then we can locate where on this curve will this slope of 3/2 occur. Okay, so once we're here, I'm going to do cross product. 6 root 3x minus 1 is equal to 6. Divide both sides by 6. I get root 3x minus 1 is equal to 1. Continue to solve for x algebraically. So square both sides. The square root goes away. I'm left with 3x minus 1 is equal to 1. 3x equals 2. Add 1 to both sides. X equals 2/3. So now I know that when x is 2/3 on this curve, that will be where the slope of the tangent line will be exactly 3/2. Okay, so in order to write the tangent line equation, we need to not only have the x value, we also need the order pair. We need the y value. So we plug 2/3 back into our function, our curve, to figure out the y value. So plug 2/3 in for x. We get 3 times 2/3 minus 1, and we get a y value of 1. So we have our order pair, 2/3 1. We have our slope that we're targeting, which is 3/2. And then we can write our tangent line equation point slope form. So y minus 1 is equal to 3/2 times x minus 2/3. Okay, you don't necessarily need to have a visual for this graph, or for this problem, but I just want to kind of show you visually what where we started with and what we ended up with. So this is the line that is given to us, 3y plus 2x equals 3. After we got this into slope-intercept form, we're able to see that the slope of this starting line is negative 2/3, but this is not the slope that we want. We want the perpendicular line. So the perpendicular line is going to be 3/2. So we want to find a location where the slope of this 3/2 will be shared on this curve. So we find the derivative. We set the derivative equal to the slope that we're after, and then in return, the derivative, when we solve for x, we can locate the exact point where that tangent line is going to occur. And once we find that x value, we plug into our original function to get the y value. And then once we have our order pair and our slope, then we end up with our tangent line equation. Again, y minus 1 is equal to 3/2 times x minus 2/3. Okay, number 3. Liquid is being poured into a large vat. After T hours, the amount of gallon of liquid in the vat can be represented as V of T is equal to 5T minus root T. And part A says, what is the average rate of liquid poured into the vat over the first 4 hours? So the thing we have to be careful about is this word average. Okay, it's not instantaneous rate of change, it's the average rate of change, average rate of liquid being poured in. So what that means is we need to find the slope between these endpoints. Okay. So rate of change of liquid over the amount. Rate of change is going to be the change in the amount divided by change in time. Okay. So this is liquid being poured in by represented by V of T. So we plug 0 and 4. To find the order pair. So plug 0 in, we get 0. Plug 4 in, we get 18. So the average rate of liquid, okay, it's just going to be V of 4 minus V of 0. So 18 minus 0 over change in time, 4 minus 0, and that reduces to be 9 halves. This is a rate, so we have to represent this with a measure of gallons per hour. Now part B says, at what rate is the liquid being poured into the vat when t equals 4? Now this is instantaneous rate of change. Okay, so instantaneous rate of change is where we do have to involve derivative and evaluating the derivative at a point. Okay, so what that means is we need to find v prime and then plug 4 into v prime. Okay, so v prime, we go through power rule, so 5t becomes 5. This is really t to the 1/2. So t to the 1/2, we go through power rule, we get 1/2 t to the negative 1/2, which is 5 minus 1 over t root 2, or 5 minus 1 over 2 root t, sorry. And then if we evaluate the instantaneous rate at 4, we can find out the exact rate of change at that moment in time. So plug 4 in for t, we get 5 minus 1/4, which is 19 over 4 gallons per hour.